Hi guys. I hope everybody is doing okay and being safe. And despite of all this situation that we're going through, but we're gonna get through all this, and I'm looking forward to seeing you again when this is over. But anyways, I need to cover some material that we didn't have the chance. And that was the last part I wanna cover and try to review for the AP exam, and that's called series. So anyways, here we go. We're working with series. We're gonna review some notation, and we have the sigma notation is adding. Go from 1 to 3, the lower limit and the upper limit, 3. This is called a finite series. Finite. Okay? Because it ends and we have a final result, final answer, final number when you add those together. These are not very interesting. The ones that we're going to be studying in depth are the infinite series, like this one. Now, the infinite series, we need to find out if there is a final number. If you add up all those terms, you have a finite number, a final answer. If it does, we say that the series converges. If it doesn't, we say that the series diverges. Okay? So there are different tests that we're going to be learning, and just to tell us whether it converges or diverges. There are only two that we'll be able to find out what the sum is, but the other ones we don't need to. As a matter of fact, they don't know. Some of those series converge, but they don't know what the final answer is, and only a few they found out the answer, the final answer, and it's very complex in the calculations. So the goal is to figure out whether it converges, diverges, and we're going to be using different tests to do that. Okay? Because there are different kinds of series. Let's start with this one. 1 to infinity, 2k, all the way. This one, you have it like this, expanded this way. It's called an open form. Well, let's put it in a closed form. We're going to be adding partial sum, the partial sum. For example, this piece right here, it was discovered by a mathematician. His name was Gauss, and I think he was 7 years old when he figured this one out. But anyways, you can see you go add those this way until he reversed the terms, and then they start adding the partial. So I added this plus this one because it's the same sum. You got two of them, and when you add 2 to 2n, you got 2 plus 2n. And this 4 plus this one, you get this, and 6 plus this one, you get that, and so on. So, but how many you gonna have? Well, if you simplify those, look, you come up with the same. How many of those do you have? You have n terms. If you go from 1 to n, divided by 2, and that's the sum. That's a closed form. So what happened when n goes to infinity then? Oh, let's see what happens. We're going to find out the big question whether it diverges or converges. So we apply the limit. Yeah? Apply the limit as n goes to infinity. And then apply the limit to that sum. Simplified. Multiply it out, divide by 2, common denominator, and then simplify, and you find out that it goes to infinity. it diverges. It turns out that this particular series, and all series that are arithmetic, all of them always diverge because you keep adding and adding and adding. Remember, arithmetic series, they have a common difference. So in other words, if you 4 minus 2 is 2, 6 minus 4 is 2, it's common difference. So you keep adding a common term. 2 to 2, you keep adding and becomes bigger and bigger. It's diverges. No. So it doesn't mean that all arithmetic series diverge. Now let's go into a more interesting one, which is geometry. That's the one this is going to ask you. Always do. How about geometric series? Well, how do you find out it is geometric? Well, the common ratio, 4 divided by 2, 8 divided by 4, is always the same. Or negative 1 divided by 1, 1 divided by negative 1 is always the same. The ratio is always the same of all series. These are called geometric. So you divide the next term divided by previous one is always the same, or is multiplying by a non-zero constant. In other words, if I multiply 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, and so on. Some geometric series converge, some diverge. Well, let's see how, what are the typical ones that converge and diverge. The general form of a geometric series is this one. You have a constant here, you have the ratio to a power. And they're going to become very crucial when we discuss power series. This is a power series, to the certain power. So you expand it, you get this. I'm not going to prove it, and different from 0. And let's go into the possibilities. The geometries converge if the absolute value of r, which is less than 1, which means between 1 and negative 1, it converges. And the sum is given by this formula. A turns out to be the first term, that one, and r is the ratio. Now, if r is greater or equals 1, in other words, greater than or equals 1, or less or equals negative 1, it diverges. Now, if you want to find the sum in general for finites, or any geometries like this. Now, when n goes to infinity, though, the only value that depends on n is r. So it means I can factor out a1 minus r, treat it like a constant, and I have this. Now, how do I know then what r is, and how do I know whether this converges or diverges? So here we go. If r is, for example, let's pick one example, one instance of summing in between 1 and negative 1. 1/2 is less than 1. And I'm going to find just this particular term, find when it's 1/2. It turns out to be 0. As you know, the limit of 1, this goes to infinity. 2 to the infinity is infinity. 1 approaches 0, the limit. Therefore, this one, which is 1/2, this is 0. It converges. It converges to that value. Look, a is the first term, whatever that value is. In this case is a, this one, and r is 1/2 in our case. Now, if r is greater than 1, it could be negative 2. I picked 2. I do the same thing. I do the same thing here. I did it in 1/2. Goes to infinity. So when I plug it into this particular expression, I get infinity. Well, that diverges. A number times infinity is going to diverge anyway. 1 minus infinity is going to be infinity anyways. So here's a proof showing you with one case or two cases. Now, but what happened if r equals 1? Well, if r equals 1, we plug in 1 here, so you're going to have 1, 1, 1, so it's A. How many A's do you have? N A's. Well, then you apply the limit to that sum of all those. And then you go to infinity. Diverges. Now, when it's r equals -1, then it's going to be 1, it's going to be -1, 1, -1, 1, -1, 1 when you apply it into r. You end up with this. And then if you have the partial sum, in other words, the first one is a, the second one is -a plus a, which is 0. The third one is, is -a plus a, -a, 3. You're adding partial sum of the terms. It turns out then when it's odd, the limit of that sum is a. The sum is going to be a, but when it's even, it's going to be 0. So you're going to have two limits. One with a and 0, not possible. So it diverges. So that concludes that it diverges. The geometric series diverges with r, including 1 and -1. Give an example. So we have the sum, this one, -1/3. You see that's this form. That's this form. In this case, you can break it down and split it into, you can write it like this. Times, making this as the a term, this one, the a constant, and you notice then that this is your r. You can go like this. This is a and this is r to the k. So if you expand it though, you notice it's geometric, which if you times it by 1/3, -1/3, -1/3, -1/3, the ratio is -1/3. Or if you divide this by this by this, you get -1/3. So it's less than 1, the absolute value less than 1. Is between 1 and -1. So therefore, it is geometric, and it converges, okay? And you use your formula, and you find out that the sum is 3/4. The sum is 3/4. So basically, you need to just identify if it is geometric, identify the value of r, identify if the value of r is between 1 and -1. If it is, it converges. You know it's going to have the sum. Use the formula and find the sum. Period. That's all you need. Converging. Converges. Okay. So, if you see something looks like this, as we previously, or like this, sorry, which means it's going to be geometric. Okay? Alright, I'm going to stop here, download it, and we go to the next topic, another series that I want to explain to you. Bye.